Hey guys, today I want to talk to you about how to turn in information about the line sets on Mitsubishi mini split heat pumps. And this may be true for other brands as well, like Daikin or Lennox or whatever else, but I'm talking specifically about Mitsubishi today. And I'm going to show you an example of line sets that were installed. And then right here you can see, you have a pretty high elevation there to a third story. You got T's and branch outs, and you've got different elbows and all kinds of complications going on. So that's what that could look like in an extreme scenario. This right here, what you're looking at is the Mitsubishi Diamond System Builder. This is the outdoor unit, and these are all of the indoor units. And when I enter the outdoor unit, I have to tell it the elevation. In this case, this unit is 2 feet above the lowest indoor unit. So our baseline is going to be the indoor unit. Over here, as you can see, I have to enter the piping length, how many bends, and the unit height in relation to the lowest unit in the system. So that's the information that I need: length, number of bends, unit height, and the location of the unit, so I can tell it right here, like, where's this at. Anyway, if I do this correctly and I enter the information correctly in the system, down here it's going to tell me how many pounds or ounces of refrigerant I have to add in the system. That way you don't have to do these calculations in the field. Now you should be able to do those calculations, but I can do this for you very easily. And the other benefit of having this syncs with Mitsubishi, so they have access to all of our designs, so that if there's any kind of a warranty concern down the road, they will see that we did the right thing designing the system, installing the system, and all of our numbers and calculations are correct. So having said that, let's go here real quick. And first of all, I just want to tell you that not all bends have to be counted. So if the bend is this sharp, or the equivalent of what you would purchase, like a 90-degree elbow that you braze in the field, those have to be counted. If the elbows, and you can get closer here, are sort of sweeping like this, this one you don't have to count, this one you don't have to count, this one you don't have to count. The only time you have to count them is if you use that black tubing bender or one of those inserts that are colored, and you make an extremely sharp turn, something the equivalent of that. This is the only thing you have to count. These ones here don't get counted. Now, when you're in an attic, when you go through a speedy channel, whenever you can, you should try to have sweeping bends, because that will allow you to have a longer linear distance that these units can run, and those won't be counted. The other reason, obviously, is for efficiency of flow of refrigerant through the system, but don't do it at the cost of having a mess inside of the speedy channel where you just don't have any space for it. So, having said that, let's talk about linear footage. So this is a very easy example over here. We're just going 20 feet over, one elbow, 8 feet across. So when you turn in this information, what you want to say is, hey, this indoor unit is located in X room. It's 8 feet high compared to the lowest unit in the system. It's 28 linear feet and has one elbow. Now remember, that's if it's this sharp. Most likely if you have a one-to-one system, you will not have any elbows, even if you're doing 6 bends. They're all going to be sweeping bends that don't count. So keep that in mind. Let's move on to a more complex system. Here we have the lowest point in the system over here in the basement, and the outdoor unit is actually 4 feet higher. So when you turn this piece of information in, you're going to say the elevation. Here's the example. You're going to say it's 0 feet high in elevation, so that tells me that's the baseline. It's going to be, let's just say 20 and 4 or whatever, so 21 linear feet. And then 0 elbows, because all of these elbows are very smooth. And then as you go up, you can see there's a 4-foot distance here, 6-foot distance here, so that's 10 feet for that unit in elevation by comparison to the lowest one, 20 feet, and then 22 feet up in the attic for the cassette. So I'm kind of blowing through this real fast, but I wanted to give you this example because when you turn in this information, it has to be accurate. We don't want to add more elbows than we have to. We don't want to say we have more elbows than we actually have, that count, and we want to be accurate with our elevations as much as possible. And obviously the linear feet is the easiest of all. One variation to tell you is branch boxes. So I kind of like half drew a branch box in here. When you turn in these 3 pieces of information for each unit, you have to do the same for branch boxes. So in this case, if this was a branch box, let's just say that this branch box is 4 feet. I'm gonna put it like right here. So let's just say it's 4 feet in elevation compared to the lowest unit in the system. Linear feet from the outdoor unit, let's just say that's like 6 feet over there. And then how many elbows are there? Again, you may have some elbows or no elbows. Sometimes for these you'll have to have a nice sharp elbow so it looks nice and neat, especially if you have multiple lines going through it. So just put whatever number that is. In this case I'll put 0, not feet but elbows. So that's how you would turn in that one. So you got to turn in these 3 pieces of information for each indoor unit. In this system, now if I had a branch box here, this one would not be these numbers that I gave you earlier, the 21 feet. It would be, 21 feet minus 6. So you're just calculating the line between that branch box and here. You're not calculating that line plus this line right here. So I hope that makes sense. If you have any questions about that, feel free to reach out, call, text, and I'm more than happy to help you out. So we have good jobs going out there and you'll have some fun.